What is tectonic movement? Tectonic movement refers to the large-scale motion and deformation of the Earth's lithosphere, which is the outermost layer of the Earth composed of the crust and the uppermost part of the mantle. These movements are primarily driven by the processes occurring beneath the Earth's surface, particularly in the mantle, where convection currents transfer heat and cause the lithospheric plates to shift. There are several key mechanisms driving tectonic movement. Plate tectonics. The theory of plate tectonics explains the movement of the Earth's lithosphere. It proposes that the Earth's surface is divided into several large and small tectonic plates that float on the semi-fluid asthenosphere beneath them. These plates interact with each other along their boundaries, leading to various geological phenomena such as earthquakes, volcanic eruptions, and the formation of mountain ranges. Divergent boundaries. At divergent boundaries, tectonic plates move away from each other. This movement is typically associated with the upwelling of magma from the mantle, which solidifies to form new crust. As the plates continue to move apart, they create features like mid-ocean ridges and rift valleys. Convergent boundaries. Convergent boundaries occur where tectonic plates move toward each other. Depending on the types of plates involved, one plate may be forced beneath the other in a process called subduction, leading to the formation of deep ocean trenches and volcanic arcs. Alternatively, if both plates are continental, they may collide, resulting in the uplift of large mountain ranges. Transform boundaries. Transform boundaries occur where tectonic plates slide past each other horizontally. This lateral movement can cause earthquakes as friction builds up along the boundary. Famous examples of transform boundaries include the San Andreas Fault in California. Mantle convection. Beneath the lithosphere, the Earth's mantle undergoes convection currents due to variations in temperature and density. These currents cause the overlying tectonic plates to move as they drag or push them along. Tectonic movement plays a fundamental role in shaping the Earth's surface over geological timescales. It is responsible for the formation and breakup of continents, the distribution of mountain ranges and ocean basins, and the occurrence of seismic and volcanic activity. Understanding tectonic movement is crucial for various fields of science, including geology, seismology, and geophysics, as it helps predict natural hazards and unravel the Earth's geological history. How does tectonic movement occur? Tectonic movement occurs through a combination of processes driven by heat and pressure deep within the Earth's interior. These processes are primarily influenced by the dynamic behavior of the Earth's mantle and crust, resulting in the continuous shifting and repositioning of the lithospheric plates that make up the Earth's surface. Here's a more detailed explanation. Mantle convection. One of the key drivers of tectonic movement is mantle convection. Within the Earth's mantle, heat from the core causes material to become less dense and rise towards the surface, while cooler, denser material sinks towards the core. This movement forms convection currents that circulate within the mantle. As these currents rise and sink, they exert forces on the overlying lithospheric plates, pushing them apart at divergent boundaries and pulling them downward at subduction zones. Ridge push and slab pull. Two important mechanisms associated with mantle convection are ridge push and slab pull. Ridge push occurs at divergent boundaries, where newly formed oceanic crust pushes older crust away from mid-ocean ridges due to the force of gravity. Slab pull, on the other hand, occurs at subduction zones, where denser oceanic crust sinks beneath less dense continental crust, pulling the rest of the plate along with it into the mantle. Gravitational forces. Gravity also plays a significant role in tectonic movement. As lithospheric plates become denser due to the cooling and solidification of magma at mid-ocean ridges, they gradually sink back into the mantle under the influence of gravity. This process, known as subsidence, contributes to the overall movement of tectonic plates and the formation of ocean basins. Magma upwelling and solidification. At divergent boundaries, magma from the mantle rises to the surface, creating new crust as it solidifies upon contact with seawater. This process, known as seafloor spreading, continuously adds material to the edges of tectonic plates, pushing them apart and facilitating the movement of the lithosphere. Shearing and faulting, along transform boundaries, where tectonic plates slide past each other horizontally, tectonic movement occurs through shearing and faulting. Stress builds up along these boundaries until it exceeds the strength of the rocks, causing sudden movements known as earthquakes. These movements can result in the offset of rock layers and the formation of fault lines. Overall, tectonic movement is a complex process driven by a combination of forces generated within the Earth's interior. The interplay between mantle convection, gravitational forces, magma dynamics, and geological structures such as faults and ridges shapes the Earth's surface over geological time scales, leading to the formation of continents, mountain ranges, and ocean basins, as well as the occurrence of seismic and volcanic activity. Tectonic movement results. Tectonic movement results in a wide array of geological phenomena and features that profoundly shape the Earth's surface and influence its geology, topography, and even climate. These results occur over long periods of time and are driven by the interactions between tectonic plates and the processes occurring within the Earth's interior. Here are some of the significant outcomes of tectonic movement. Formation of mountain ranges. One of the most prominent outcomes of tectonic movement is the formation of mountain ranges. This occurs primarily at convergent plate boundaries, where two tectonic plates collide. The intense pressure and compression resulting from this collision uplift the Earth's crust, leading to the formation of towering mountain ranges such as the Himalayas, the Andes, and the Alps. Creation of ocean basins. Tectonic movement also leads to the creation of ocean basins through the process of seafloor spreading. At divergent plate boundaries, new oceanic crust forms as magma rises from the mantle and solidifies. As the plates move apart, this newly formed crust accumulates, eventually creating expansive ocean basins such as the Atlantic Ocean. Volcanic activity. Tectonic movement is closely associated with volcanic activity. At convergent plate boundaries, where one plate subducts beneath another, the subducted plate heats up and releases water and other volatiles, causing partial melting of the mantle above it. This molten material can then erupt at the surface, leading to the formation of volcanic arcs and chains such as the Pacific Ring of Fire. Earthquakes. The movement of tectonic plates also results in earthquakes, which occur along faults where the accumulated stress is released suddenly. Earthquakes can happen at various types of plate boundaries, including transform boundaries, where plates slide past each other horizontally, and convergent boundaries, where plates collide or one plate subducts beneath another. Continental drift. Over geological time scales, tectonic movement causes continents to drift across the Earth's surface. This process, known as continental drift, was proposed by Alfred Wegener in the early 20th century and is now widely accepted as a fundamental aspect of plate tectonics. It explains how continents have moved and repositioned over millions of years, leading to changes in global geography and climate. Formation of rift valleys. At divergent plate boundaries within continents, tectonic movement can lead to the formation of rift valleys. As the lithospheric plates pull apart, the crust stretches and thins, creating linear depressions in the landscape. Over time, these rift valleys can develop into new ocean basins if seafloor spreading continues, as seen in the East African Rift. Subduction zones and deep ocean trenches, where oceanic plates converge with continental plates, subduction zones form. The denser oceanic plate sinks beneath the less dense continental plate, creating deep ocean trenches such as the Mariana Trench, the deepest point on Earth's surface. These trenches are the result of intense tectonic forces and are associated with seismic activity and volcanic arcs. Formation of mineral deposits. Tectonic movement can also lead to the formation of mineral deposits through processes such as hydrothermal circulation and magmatic activity. The movement of fluids and magma within the Earth's crust can concentrate valuable minerals in specific geological settings, leading to the formation of economically significant ore deposits. Overall, tectonic movement is a dynamic process that shapes the Earth's surface and drives geological activity on a global scale. Its effects are pervasive and diverse, influencing everything from the distribution of land and oceans to the occurrence of natural hazards such as earthquakes and volcanic eruptions. Understanding tectonic movement is crucial for geologists, seismologists, and other scientists studying the Earth's structure and history. Tectonic movement types. Tectonic movement encompasses several distinct types, each characterized by specific interactions between tectonic plates and resulting geological features. These movements are fundamental to the theory of plate tectonics and play a crucial role in shaping the Earth's surface over geological time scales. Here are the primary types of tectonic movement. Divergent boundaries. Divergent boundaries occur where tectonic plates move away from each other. This movement is driven by the upwelling of magma from the mantle, which solidifies to form new crust. Divergent boundaries are typically found along mid-ocean ridges, where oceanic plates are separating. As the plates diverge, they create new oceanic crust, leading to the formation of linear features on the ocean floor. Examples include the Mid-Atlantic Ridge and the East Pacific Rise. Divergent boundaries can also occur within continents, leading to the formation of rift valleys, such as the East African Rift and the Basin and Range Province in North America. Convergent boundaries. Convergent boundaries occur where tectonic plates move towards each other and collide. Depending on the types of plates involved, convergent boundaries can lead to different geological features. When an oceanic plate collides with a continental plate, the denser oceanic plate is typically subducted beneath the continental plate, leading to the formation of deep ocean trenches, volcanic arcs, and mountain ranges. Examples include the Andes Mountains and the Cascades Volcanic Arc. When two continental plates collide, neither is subducted due to their similar densities, resulting in the uplift of large mountain ranges, such as the Himalayas and the Alps. Transform boundaries. Transform boundaries occur where tectonic plates slide past each other horizontally. This lateral movement is accommodated by strike-slip faults, where the motion is predominantly horizontal. Transform boundaries are characterized by frequent earthquakes resulting from the release of accumulated stress along the fault. The San Andreas Fault in California is one of the most well-known examples of a transform boundary, where the Pacific Plate and the North American Plate are sliding past each other. Oblique slip boundaries. Oblique slip boundaries combine both strike-slip and convergent or divergent movements. These boundaries involve both horizontal and vertical movements along faults. The exact nature of the movement depends on the relative orientation of the tectonic plates involved. Examples include the Sumatran Fault in Indonesia, where the Indian Plate converges obliquely with the Sunda Plate, leading to both strike-slip and thrust faulting. Continental drift. While not a boundary per se, continental drift refers to the movement of continents across the Earth's surface over geological time scales. It is driven by the movement of tectonic plates and the processes associated with plate tectonics. Continental drift has resulted in the rearrangement of continents over millions of years, leading to the formation of supercontinents such as Pangaea and the current distribution of land masses on Earth. These various types of tectonic movement are essential for understanding the dynamic processes that shape the Earth's lithosphere and drive geological activity, including earthquakes, volcanic eruptions, and the formation of mountain ranges and ocean basins. What geologic formations are caused by tectonic movement? Tectonic movement is responsible for a diverse range of geological formations and features that shape the Earth's surface. These formations result from the interactions and forces exerted by moving tectonic plates over millions of years. Here are some of the significant geologic formations caused by tectonic movement. Mountain ranges. Convergent plate boundaries, where tectonic plates collide, are responsible for the formation of mountain ranges. The intense pressure and compression generated during collision uplift the Earth's crust, leading to the formation of towering peaks. Examples include the Himalayas, formed by the collision between the Indian Plate and the Eurasian Plate, and the Andes, formed by the subduction of the Nazca Plate beneath the South American Plate. Volcanic arcs and chains. Subduction zones, where one tectonic plate is forced beneath another, often give rise to volcanic activity. The subducted plate heats up, releasing water and other volatiles that cause partial melting of the mantle above it. This molten material can erupt at the surface, forming volcanic arcs and chains. The Pacific Ring of Fire is a prominent example of a volcanic arc associated with subduction zones. Deep ocean trenches. Subduction zones also create deep ocean trenches, which are elongated depressions in the ocean floor. These trenches form where the subducted oceanic plate descends into the mantle, creating a deep trough. The Mariana Trench, located in the western Pacific Ocean, is the deepest ocean trench on Earth, reaching depths of over 11,000 meters, 36,000 feet. Mid-ocean ridges. Divergent plate boundaries, where tectonic plates move apart, create mid-ocean ridges, underwater mountain ranges that span the Earth's oceans. Magma from the mantle rises to the surface along these boundaries, solidifying to form new oceanic crust. The Mid-Atlantic Ridge is the longest mid-ocean ridge system, stretching from the Arctic Ocean to the Southern Ocean. Rift valleys. Divergent plate boundaries within continents can lead to the formation of rift valleys. As the lithospheric plates pull apart, the crust stretches and thins, creating linear depressions in the landscape. Over time, these rift valleys can develop into new ocean basins if seafloor spreading continues. The East African Rift is an example of a rift valley in the process of splitting the African continent. Faults and fault zones. Tectonic movement along faults can result in the formation of fault lines and fault zones, where rocks on either side of the fault have moved relative to each other. These features are associated with earthquakes and can range from small fractures to large-scale fault systems. The San Andreas Fault in California is a well-known example of a major transform fault. Folded and thrust belts. Convergent plate boundaries can also lead to the folding and faulting of rock layers, resulting in folded mountain belts and thrust faults. These features are formed by the intense compression and deformation that occurs during plate collision. The Appalachian Mountains in North America and the Alps in Europe are examples of folded mountain ranges. Ophiolites. Ophiolites are sections of oceanic crust and upper mantle that have been uplifted and exposed on land due to tectonic processes. They provide valuable insights into the composition and structure of the oceanic lithosphere. Ophiolites can be found in various mountain ranges around the world, including the Troodos Mountains in Cyprus and the Oman Mountains in the Arabian Peninsula. These geological formations are just a few examples of the diverse and dynamic landscapes shaped by tectonic movement. They highlight the profound impact of plate tectonics on the Earth's surface and provide important clues about the planet's geological history and processes.